Welcome to 1-2 linear functions. This unit, we're going to be talking just about the graph of a straight line, which we use a lot in math, and you'll use it a lot here in calculus. Just a little different notation here. We're going to start this unit with the question, how many units must be sold for a firm to break even? This is business calculus. You guys are going to be doing a lot of problems with maximizing profit, minimizing cost, that type of thing. So this notation is just a little bit different. Instead of having y equals 5 minus 3x, we use a lowercase f here, or obviously we can use a lowercase g, lowercase h, kind of write it in italics. F of x equals 5 minus 3x is another way of saying that. F of x, it means this function is doing something to the variable x. So in this case, we have g of x equals negative 4x plus 5. And they're asking us to find g of 3. So all that means is use the g function, but substitute 3 everywhere you see x. So that's negative 4 times 3 plus 5, which will be negative 12 plus 5. G of 3 is negative 7. Okay? That's all. It's just a different notation. Now, I want you to make sure you realize what this means is if I was going to plot a point, the x coordinate is 3. The y coordinate that goes with that is negative 7. Okay, the point 3, negative 7 is on this g of x function. Okay, if I was going to graph it. Sometimes people, when we lose the y coordinate, we're not using the letter y, we're using f of x instead. People get that confused. This is still negative 7 is the y coordinate that goes with 3 as the x coordinate. G of 0, I would put 0 in for x. Negative 4 times 0 is 0. 0 plus 5 is 5. G of negative 2, I would put negative 2 in for x. Negative 4 times negative 2 is positive 8. Plus 5 is 13. So the point negative 2, 13 would be on the g of x function. G of b, that's a little bit more awkward. I'm just putting b in for x. So g of b is negative 4b plus 5. Sometimes people have trouble with that. When in some ways it's easier. I didn't have to actually do any math. I just had to put b in where the x was. So instead of negative 4x plus 5, it's negative 4b plus 5. It might seem silly, but sometimes, that does come into play. Okay, so that's the notation. It's called function notation, f of x notation, okay, instead of the y. Here we have a supply and demand question. Suppose that Greg, manager of a giant supermarket chain, has studied the supply and demand for watermelons. He's noticed that the demand increases as the price decreases. Makes sense, doesn't it? He's determined that the quantity in thousands demanded weekly, which we're going to let be the letter Q, and the price per watermelon, which we're going to let be P or D of Q. Okay, they're going to be used interchangeably. We might say P or we might say D of Q. Okay, functional notation, but it's 9 minus 0.75 Q. All right, so find the quantity if the price is 5.25. So we have to be careful, guys. We're putting 5.25 in for the price, not the quantity. We're finding the quantity. So then I have 5.25 equals 9 minus 0.75 Q. Okay, and then what we're going to do is just do our math with that. We'll, subtract 525, adds 0.75 Q over here, and divide. So I'm going to have 0.75 Q equals 375, okay, because I'm taking 9 minus 525. I will then divide by 0.75, and I end up getting, if you take 375 divided by 0.75, you get that Q equals 5. Now that doesn't mean I'm getting 5 watermelons. Be careful. The quantity in thousands. So whatever answer we get, we know that's in thousands. Okay, so at a price of $5.25, the demand is for 5,000 watermelons. All right. If I do the same thing for $3.25, I would write 325 equals 9 minus 0.75 Q. All right, and then I would do that same math. 0.75 Q, I would take 9 minus 325 and get 575. Do my division, okay, and you end up getting 7. Okay, is everybody all right with that? And so at a price of $3.75, the demand increases to 7,000 watermelons. The price went down, the demand went up. Okay. Greg also noticed that the quantity of watermelons supplied decreased as the price decreased. Okay. The quantity of watermelons supplied decreased as the price decreased. Okay. So the supply of watermelons, doesn't that make sense? Because they're gobbling them up, right? So the supply is going down. It looks like that equation is just 0.75 Q. So we're going to graph both of those equations on the same axis. Okay. If I take 9 minus 0.75 Q, obviously that slope is negative. So here's my demand function. Okay. As the quantity is getting bigger, okay, this is decreasing. Now the supply, okay, is increasing. Okay, so we have our supply function 0.75 Q right here. That's our supply based on our quantity. Okay. And here's our demand function. This point right here, 4.5, is something we call the break-even point. Okay? Both the supply graph and the demand graph pass through the point 4.5. If the price of a watermelon is more than $4.50, then the quantity supplied ends up exceeding the quantity demanded, and then there's a surplus of watermelons, right? At a price less than $4.50, the quantity demanded exceeds the quantity supplied, and there's a shortage of watermelons. Only at a price of $4.50 will quantity demanded and supplied be equal. $4.50 is something we call the equilibrium price, okay? When the price is $4.50, then the quantity demanded and supplied are both 6,000 watermelons. That's the equilibrium quantity. Okay, so just an idea when some of that vocabulary, they'll ask you to graph the supply and demand function on the same coordinate system, and then you can see where the break-even point is. Okay, a small company decides to produce video games. The owner finds that the fixed cost for creating the game is $5,000, and after that, they spend $12 per game. Okay, so this is the formula for the cost. All right, it's $12 per game plus $5,000 to start. Okay, so that is our that's our equation. Cost is 5,000 plus 12x. What we call 12, which is the slope, when you think about graphing a line, we refer to that as the marginal cost. That approximates the cost of producing one additional item. Okay, marginal cost. Get used to hearing that in economics. Marginal cost is the slope of the cost function. Okay, so therefore we have our linear cost function. It's usually in the form mx plus b, M, I know we're used to saying that's the slope, but we're going to be saying, well, that's the marginal cost. That's where the M comes from, guys. You know how we're always asking, when you're in algebra, you're like, why do you use M for slope? Why not S or something? Well, it's the marginal cost. And B is the fixed cost. Fixed, stays the same. It doesn't depend on X. Conversely, if the fixed cost of producing an item is B and the marginal cost is M, then the linear cost for producing X items is MX plus B. Okay? So the marginal cost to make X batches of a prescription medication is $10 per batch. As soon as you see marginal cost, you know that's the slope. The cost to produce 100 batches is $1,500. We want the cost function. Okay? So all I can tell you right now is that the cost function is 10x plus something. I don't know the fixed cost. They didn't tell me the fixed cost. Okay? I don't have that. However, they did tell me that when X is 100, the cost is 1,500. So I'm going to put 1,500 in for the cost and 100 in for X. And that'll help me find my fixed cost, right? 10 times 100 is 1,000. Subtract that from 1,500. I have that my fixed cost is 500. Therefore, the cost function is 10x plus 500. Okay, we needed the general cost function and we didn't have the fixed cost. A company has a fixed cost of $12,500 and the total cost to produce 1,000 widgets is this. Find the cost function. Same thing, except I'm given different information, but the process, guys, is the same. As long as you know that the cost function is always the marginal cost or the slope, I don't know what that is, times the number of things produced plus the fixed cost. Oh, I do know that. That's 12,500. Okay. Then we have to find the cost function. Well, I'm going to use 1,000 for X, 13,200 for the cost. 260 equals M times 1,000 plus 1250, 12,500, I mean. And then I'll do the rest. I'll subtract 12,500 and get 760. Okay, and so we have 760. Oops, that's gone crazy again. My pen does that sometimes. I don't know what I hit. 760 equals 1,000 M. Divide by 1,000 and you get 0.76. So the cost function is 0.76x plus 12,500. So now I know that the marginal cost is 76 cents per widget. Okay. When we're doing break-even analysis, we have things called the revenue, the profit, okay, and the cost. All right. The revenue is the amount of money that we make. All right. Basically, that's how much did I charge for the thing and how many did I sell? Okay. I'm at a lemonade stand. I sold 100 cups of lemonade and I charged $5 each. Great. I made $500 revenue. However, that's not my profit because I had to make the lemonade. I bought the lemonade. I bought cups. I bought stuff to make a sign. I don't know, whatever all that was. The profit is the revenue minus the cost. Okay? So you have to know the difference between revenue and profit. Profit is revenue minus cost, and revenue is always just price times the number of units. The number of units at which the revenue equals the cost is called the break-even quantity. Okay, so you want to set revenue equal to cost, and you'll find that break-even quantity. You also could find that by setting the profit equal to 0. Okay, because since profit is revenue minus cost, you could do it that way as well. The break-even point is the corresponding ordered pair and indicates the point of 0 loss or profit. Okay? So we just have one more little problem to do in part 2. I'll see you then.